Hello everyone, I hope all of you are doing fine. I have come up with another video. This time I'm going to talk about pan sharpening. Pan sharpening is the technique of enhancing low satellite resolution into high satellite resolution. In the Landsat 8, uh, Landsat 8 bands such as blue, green, red, up to band 7 have 30-meter resolution, while the band 8, which is panchromatic band, has 15-meter resolution. So using band 8 we can increase the resolution of band 2 to 7, or we can use this panchromatic band to increase the resolution of thermal infrared band as well. This time I'm going to show you how to do it for the blue to shortwave infrared. To start, I have to download satellite imagery, which I have already done. If you don't know how to download satellite imagery, first of all you have to go to USGS website, and then you can create your account there, and then you can proceed from there. This is before pan sharpening. Let me change its enhancement setting. I'll keep it linear 2. Okay, let me just turn this one on. You can see this feature, and let me turn this after pan sharpening imagery. Can you able to differentiate what we actually accomplish after pan sharpening? I think you can, definitely, because imagery still looks fuzzy, but after pan sharpening it looks much better, and I'm going to show you how to do that. Let me close ENVI. Okay, for that I have to go with ENVI 5.6 plus ideal. You can work with basic ENVI like this one, you can do that. So I have to go with plus ideal version. I have created a layer stack in the ArcGIS. I'm going to load my layer stack from here. Landsat 8 composite. This is my TIFF file. Okay, let me change in its optimization. I'll change it to linear 2%. This is 3 to 1. Now I'll keep 3 to 1, and then I'll also load my panchromatic band as well. My panchromatic band, which is band 8. Let me find it. Nope, not this one. Okay, this is my band 8. So let me load it. Okay, I have successfully loaded panchromatic band as well. I'll show you what its spatial resolution is. You can go to map info and check. It is 15-meter resolution. Meanwhile, the composite band has, let me show it, 30-meter resolution. So we are going to change spatial resolution of panchromatic of composite imagery to 15-meter resolution. For now it is 30-meter. After pan sharpening it is going to be 15-meter. So the panchromatic algorithm that we are going to use is Gram-Smith. There are multiple algorithms, but this one is efficient for vegetation and urban analysis, so I'm going to use this one. For the low spatial resolution multi-band input file, you can read here our low resolution is composite 1. I have shown you from the metadata as well. It has 30-meter resolution, so I'm going to select this one. spectral subset, you can see there are 7 bands, so I'm going to click OK, then OK. For the higher spatial resolution, I'm going to select band 8, which is panchromatic band. Okay, then for the sensor, I'm going to select Landsat 8 only. Here I'm going to select bilinear resampling technique, and the output format will be ENVI. You can select TIFF as well, and then output I'm going to select for the output band. Let me create one folder where I can keep my imagery. Okay, I'll name it as output. Okay, then I'll name it as a pan sharp. Okay, and then I can proceed. It will take a couple of minutes because this imagery is pretty large. I haven't clipped the imagery, so it might take up to 10 minutes. Finally, my pan sharpening is done. It took around 5 minutes. It depends on the which devices you're using. It can take up to 10 minutes, so don't worry, it will work. If you follow the instruction that I have shown you, it will definitely work. Now you can see this is the pan sharpening band. It is in the 3-to-1 combination. You can see. Let me zoom into one feature and then we'll see what is the change after pan sharpening. Let me focus on this feature. It can be a fellow field. If I turn this off, you can see it looks much fuzzy. So now it looks much better. The features are much clear in the 15-meter resolution than in 30-meter resolution. Of course it will, because it is 15-meter resolution, so it has to, right? Yeah, let me show its metadata as well. You can go to metadata, and in the map info you can see now it's 15 meter. You see in 2 vertical views. Let's choose 2 vertical views. From A, I'm going to load my imagery, pan sharpening here, and then in another view I'm going to load my raw imagery before pan sharpening here, and I'm going to focus on some portion of the area. Let me focus on this area, and then okay, and then here as well I'm going to zoom into that area, and we can tell how imagery improved after pan sharpening. Now you can see and observe yourself what change pan sharpening did to your imagery. For my case, it definitely improved the spatial resolution. The whole imagery itself looks much clearer now. If I choose another band combination, I hope you already know how to choose the band combination by yourself. You can explore what each band combination means in the USGS website. From there you can choose your band combination and try to visualize by yourself. Okay, that's it for today's tutorial. I hope you have learned something new which you can apply in your research. Pan sharpening is very valuable for the research where you need higher spatial resolution and higher temporal resolution. There is a trade-off in remote sensing where you can either get higher spatial resolution or you can get higher temporal resolution. To achieve higher spatial and temporal resolution, you have to use pan sharpening. Let's suppose you want to use MODIS for your research and you need higher spatial resolution as well. For that case, what you can do is you can use Landsat and MODIS combine to create the imagery which has both higher spatial and higher temporal resolution. To combine Sentinel and Landsat imagery to achieve higher spatial resolution, you can just do it using pan sharpening technique. You can do it for thermal infrared band as well. Landsat has 100-meter resolution for thermal infrared. You can use pan sharpening tool to increase its spatial resolution. You can use panchromatic band as a higher spatial resolution to achieve 15-meter resolution for thermal infrared band. Not just for the Landsat, Sentinel and MODIS, you can definitely apply this technique for the GOI, Worldview and many other satellite. I hope you have learned something new from this tutorial. If you don't want to miss future video regarding ENVI, considering subscribing this channel. Like this video, share it with your friend, and up until next time, see you. Thank you so much.